Hello, my name's Adam.
I'm Gabby, and this is TiVo.
And that's Gator. And today we're going to talk about math.
Enjoy the lesson.
Yeah. To start out, there are 4 different survey methods, and they can be used in various situations in statistics and the world. These survey methods are simple random survey, or an SRS, stratified, cluster, and systematic random samples. Though there's a fabled 5th survey method called a convenience sample, but we don't use it because it chooses the easiest outcome and is never used. To add on to that, simple random surveys, SRS, includes 1 step, while stratified, cluster, and systematic are a little more complex, including 2 steps. Also, everything must be random. We'll start with a simple random survey, or an SRS. In an SRS, the sample must be chosen in a way that gives each being an equal chance of being chosen for the sample. The pros of an SRS are that it only has 1 step, it's effective, and a quick way of sampling. The con of an SRS is that the process can be too simple. Next is a stratified random sample. In a stratified random sample, you organize the population into groups and take some from each group. The pros of a stratified random sample is that you avoid cluster sampling, but also that the population is organized into groups and getting a sample from each group. The cons of a stratified random sample is that it may take some time to organize people into groups, and that it's stratified. Another sample is the cluster random sample. In a cluster sample, you organize a population into groups, but take all from one group. Cluster is the same thing as stratified sample, except for one key thing. What is that? If you answered something along the lines of that, you will take all from one group instead of some from all, then you are correct. The pros of a cluster sample is that it avoids stratification and the population is narrowed down. The cons of a cluster sample is that it's a cluster sample and it may take some time to organize populations into groups. Finally, there's a systematic random sample, which selects a sample from an ordered arrangement of a population by randomly selecting one of the individuals and choosing every nth one after that. The pros of a systematic random sample are that the population is already arranged and that it's easy to choose people. The cons are that people are too simply chosen and that it isn't needed in smaller populations. The pros of all the types of samplings are that they're all random, they reduce bias, and each of them can be completed in a fairly short time. A con they all have in common is that there's always room for bias or confounding. Examples are surveys, contests, mainly raffles, game shows, experiments, stats class examples, weight loss articles, toothpaste, and medical recommendations.
The practice AP question is, at an assembly, there are 100 students. The school is trying to figure out how to separate them into groups and which students they would use in their experiment. Part A, design a simple random sample. Part B, design a stratified sample. Part C, design a clustered sample. And Part D, design a systematic random sample. Pause now if you want to try it yourself.
Some possible answers to this question and its parts is that for part A, randomly choose 30 for the sample. Part B, divide by grade 9, 10, 11, and 12, and randomly choose 7 from each group. Part C, divide by grade 9, 10, 11, 12, and randomly choose 1 group and choose all from that group. And finally, Part D, randomly select a person from the group ordered alphabetically by last name and then choose every 5th person from that person for the sample. 1, go. Okay, so I'm going to show some examples of these samples. So in SRS, you just randomly choose some from a group, like so. And then for a stratified random sample, we have groups over here, and you're gonna take like a couple from each group, and so forth. And then for a cluster sample, you're going to take all from one group for the sample. And finally, back over here, let's say you ordered them just randomly, right? And I picked this one. Let's just say every third one after that is included in the sample. So these are ignored, and this is the third one. So finally, there are key takeaways. The first one is there are a variety of situations each one can be used in, like the types of samples. And depending on each sample, an experiment can be very different, or the outcomes can be different. And finally, each sample is viable for designing an experiment.
Hope you enjoyed the video.